All right. So, you guys, I think, are feeling pretty good about the power rule, right? If I said that question, get 8x to the fourth, the derivative, we would take the 4 times 8 to get 32, right? And then dump your power by 1, so 32x to the third. So today, guys, we're going to talk about section 4.1, which is titled Powers and Polynomial Derivatives. We've kind of had some exposure to this, but some of the things are going to get a little bit more difficult. We've got to start being able to apply it to all types of functions here. So, question today, what is the relationship between the derivatives of functions for a particular x value, and how are the slopes of the graphs related? All right? Guys, we've talked about derivatives being nothing more than a slope at a certain x value, right? We've talked about that a lot in chapter 2. So our goals today, we're going to start looking at using shortcuts for differentiation. Guys, what's the derivative of a constant? If I say, what's the derivative of 6? 0, because if I graphed f of x equals 6, that'd be a horizontal line. That slope would be 0. Okay? We're going to look at the derivatives of sums and differences, which are pretty much polynomials that you're going to look at today. And then we're going to find derivatives of powers of x here. So nothing real earth-shattering in terms of what the question is asking and in terms of what the goals are. Things are just going to take a little bit different. Yeah. Both you can go ahead. You can go. Okay. All right. It's kind of hard to read up there. Maybe I'll blow this up one more time. Derivative of a constant multiple right here says the following, guys. The derivative of a constant multiple says this: if f is differentiable and c is a constant, then the derivative with respect of x of c times f of x is equal to c times f prime of x. Let me give you an example of what this means. Suppose we had the function f of x right here, kids. Can I just use that 8x to the fourth example again, kids? Okay. This constant multiple thing basically says, well, there's a coefficient out in front of that function. What's the coefficient of 8x to the fourth? 8. This basically says if you wanted to do f prime of x, you could take this constant of 8 out front. This could be, so if I wanted the derivative of f prime of x, you already know f prime of x is equal to what, kids?
32x.
Now another way to think about this constant multiple thing is this. That constant multiple thing could be moved out front. So the derivative could have been 8 times the derivative of x to the fourth. What would the derivative of x to the fourth be? Pretend the 8's not here. 4x to the third. I could have done 8 times 4x to the third. That's like this common multiple times that derivative of 4x to the third. This is still going to equal what at the end, kids? 32x. Okay. So guys, the constant multiple rule, if there's some value out front, some coefficient out in front, you don't really need to worry about that till the end. You could do the derivative of x to the fourth, say it's 4x to the third. I think that's kind of...
It's the same thing.
It's the same thing. I just think it's probably an extra step that you really don't need to worry about. Because the power rule, you already know this. I'll rewrite it down here if you want to write it. The derivative with respect to x, this derivative with respect to x, this d dx just means f prime of x. You remember that, right? The derivative with respect to x of any function, x to the n, is equal to, okay, where does the coefficient, I'm sorry, where does the exponent go, kids? The power goes out front, so it becomes x, or n times x. What do we do with the power then? So to the n minus 1, that's what this is saying. So again, if I go back to what we had up here, if f of x was equal to 8x to the fourth, then what did f prime of x become, kids?
32x.
Yep, you pull a 4 out front. 4 times 8 is 32. X to the third again. So you know that already, right? Okay. And then guys, the derivative of a sum and difference, you know this already. We just haven't talked about in terms. But if I have some function h of x or f of x, the derivative of some function f of x plus g of x is simply f prime of x plus what? You guys get your magnifying glasses out. It would be f prime of x plus g prime of x. So all this is really saying is this: if I had a function, f of x was equal to, and you've done these before, 12x to the third plus 6x squared. You guys agree f prime of x is just the derivative of the first term times the derivative of the second term? So what's the derivative of the first term there?
36x squared.
36x squared. What's that?
12x.
Okay, so you know that. So that's just called the sum and difference rule right there. If you have like a bunch of functions like the 12x to the third and the 6x squared being added or subtracted, it's just the derivative of the overall functions, the derivative of each term added or subtracted from each other. Okay? So guys, let me ask you this question. In terms of the vocabulary and these rules, is there anything that's new at all right now? If I had to say, man, if this is all we had to do today, if this is all we had to do, I would say you're probably going to be in this kind of a mood, right? Right? Yeah. Yep. If that's all we had to do, we'd be happy, right?
Yeah.
Well, we're going to keep those rules. Unfortunately, these problems are going to become a little more difficult. Okay? But we're still using the power rule. Okay? Everything's going to be power rules today. Power rule, power rule, power rule. Okay? So, first function we have to differentiate is 5 times x to the 8. Okay? Thoughts on how to do that, kids?
5 times x to the 8?
Close. It's going to be 5 times x, but if I move this x to the 8 to the other side, kids, this would be
Wait, why
x
is it?
to the
I'm just gonna use my
negative 8, right?
Oh, yeah.
So we're going to call this function. We might have to rewrite stuff. When we use these shortcuts right here to differentiate, kids, I'm going to make a note right here after a rewrite. Okay? Guys, this is the same as 5 times x to the negative 8 power here. So would it be easy to use power rule now? Hey, I'm going to pull out negative 8 out front. So what's the negative 8 times the 5 going to get you?
Negative 40.
Negative 40. X to the
7.
close. We're subtracting. So if we're at negative 8 and go down one more, now where are we? Negative 9. Now guys, the thing that you're going to want to be making sure is that you get stuff back in the proper context, or what they would consider to be simplest form. You're not really going to want to work with negative exponents. So in the end, this would equal negative 40 over what?
X to the 9.
There's your derivative for that. Okay? All right, this next one didn't quite write as much as I wanted to, as well as I wanted to, but you guys, that's really x to the 8/11th power. Okay, so it's already written as a power for us. Help me out. Where would the 8/11ths go to? Okay, so I'm going to write this as x. 8/11ths is out front, right? 8/11ths x. Gotta subtract 1 from 8/11ths. Ooh, close. Negative 3/11ths, yep. Subtracting 1 from this is like subtracting 11/11ths, which would be negative 3/11ths. Okay? Now in proper form, kids,
8/11ths x over 3/11ths.
yeah, and here's what I would tell you. If that x is a negative exponent, that x is really kind of up top to start with because we didn't change anything. So if I wanted to make that a positive exponent, I would move that to the bottom. So you could probably call this 8 over 11x to the 3/11th power here by power rule. Okay? Now here's the situation. If you gave me this whole answer right here, I'll get rid of this little box right here. If you gave me this as an answer on a quiz or test, I'd give you credit, okay? I think for the problems that I'm gonna assign odd-wise when you're checking in the back, this is probably the form they're gonna choose to put it in right here. Okay? Make sense to everybody? Okay, let's see what you remember about. Problem's pretty radical. Let's see what you remember right here. Remember how to write radicals in terms of exponents? That fifth root of x is the same as x to what power? Close. 1/5. Okay, so let's rewrite this as. Oops. Let's write this as, how about 4 over x to the 1/5? But guys, I can't really use x to the 1/5 in the bottom, so we should probably move that up with the what?
Top.
Okay, and if I move that x to the 1/5 up top, what kind of 1/5 are you going to have there?
Negative.
So we're down here to wrap around 4 times x to the negative 1/5 power. Okay, you ready to go on derivative, kids? Okay, pull the power out front. So negative 1/5 times 4, wouldn't that be negative 4/5?
Yep.
Okay, so this is going to become negative 4/5. So the derivative becomes negative 4/5 x to what power? Gotta subtract 1 from negative 1/5 already.
It would be negative 6.
Negative 6/5. So that's subtracting 5/5 again. So to the negative 6/5. All right, I'm going to make some room in this box here. Again, if you gave that to me on a quiz or a test or anything like that, would I accept it?
Yeah.
Yes, I would. That's pretty good work right there, okay? When you're looking things up in the back of the book as you do your assignment to know if you're on the right track with the proper answer, they're probably going to say,
Negative 4 over 5x to the 6/5.
say that again for me, Ellie. Let me catch up though. Hang on a second.
Well, I don't know if it's right. but
Well,
it
I
would
think it sounded right to me. I like what you said.
be Negative 4 over 5x to the 6/5.
Yeah, if this x is a negative exponent, this x is really kind of up top when it's out by itself here. It's like negative 4 times x to this. And 5 is kind of alone in the bottom. But if I want to make this a true derivative, this one becomes negative 4 over 5x to the, you said 6/5 power, right? Now kids, sometimes people will, like that 1/5 power that was up there, would it have been possible for me, what's 1/5 as a decimal? Could I call that 22 up there though if I wanted to? I sure could have, okay, which means negative 6 over 5 would have been negative 1.2. You can think of it that way. I'm going to leave this 6/5 here because that's the way we started it, fraction form. But there's our derivative right there. Kids, I think you understand the application of the power rule very well. However, talk to me about the complexity of these problems compared to what you've seen in the past. A little more difficult, aren't they? The idea is you have to rewrite them. You got to have some number and then x follow it so that the power rule can work, okay? Now we're going to talk later on down the road about what's a quotient rule. Guys, a quotient is simply a solution for division, isn't it? There's going to be rules for this other than the power rule moving forward later on. We'll talk about what that looks like, but just real quickly, have you guys got what you need first page there? All right, let's try some more. You ready for page 2? Let's head to page 2. I'm so excited to do these problems because these are the ones that I wrote on that little sketch pad yesterday, and it was fun. And it recognized all that. Isn't that cool?
Oh.
I see you guys share the enthusiasm that I have.
Wow, Carson, that's so great.
Oh, I went home last night. I was so excited about it. I made even more problems for you.
Oh.
I'm kidding. You think I have no life when I get home?
Well,
My life is my puppy in South Park on Wednesdays. Okay. He's down, killer. All right. Yeah. All right, guys. How could I write this cube root of x right here?
Carson, that's not the top of the page.
Yeah.
Oh, thank you.
Oh, that one's easy.
I made these pages really big so the top is really tall. Heck, we've got more to do. All right, you guys, listen, I'm gonna give you 3.14 seconds to tell me the derivative here.
10x plus 3.
10x plus 3. I'm just gonna write them down. I'm gonna start getting in this idea of writing f prime of x here would equal. We've seen this before, right? That's very simple. But what happens? Okay, this is where I start to worry. Ay is right. Okay. Kids, is this x underneath the root sign here?
No.
No, it's not. So what we say is this. This is kind of, guys, if I had 4x to the 5th out here, pretend that root wasn't there. Just pretend the root wasn't in there. Wouldn't you call this 35x to the 4th? Okay, so this is simply going to be 5 times what, kids?
Root 7.
So I'm going to write this down as f prime of x. Okay, 5 times root 7. Shoot. I better, well, no. 5 times root 7, x to the what here, kids? 4. Okay, do you understand the first part of that derivative? Okay, now, I want you to think and looking at that part, x to the 24th over 12. If I had x to the 24th over 2, divided by 2 is the same as what fraction? So isn't that like 1/12? Isn't this like 1/12 times x to the 24th?
Yeah.
So think of this part right here. Think of this part as 1/12 x to the 24th.
Wait, back up. How'd you get that 1/12 figure?
Okay, so if I had this right here, if I had x to the 6 over 2, isn't that like 1/2 times x to the 6th? So if I have x to the 24th over 12, isn't that 1/12 of x to the 24th? Okay, so the derivative for this part, my friends, we're going to take 24 times what fraction, really?
112.
So that'll be like 24 over 12, which is going to turn into what value? 2. You see that there? So this is going to be plus 2x. Okay, subtract from your power of 24. 23. Okay. What's the derivative of pi?
Is it just pi?
I always say, my wife makes a pie, and I say I take the derivative of it. Because what's the derivative of 6?
Non-existent.
It's 0. Isn't 6 a constant number? Isn't 6 some constant number? Isn't pi some constant number? So what's the derivative of pi going to be? 0. Start with pi. I differentiate the pi. It's gone to 0. What's the derivative of e? E is some number too, isn't it?
0. Yeah, it's just 0.
Okay. Are we done?
We're done.
Okay. Make a note up here. Pi and e. These are what? Derivative of any constant is going to be 0. So we are just done.
I just stop. That's disgusting. Imagine.
Okay, this next one right here is something that gets kids all the time. It gets them all the time when they have to take a derivative. And I'm like, don't make this difficult on yourself. Guys, anytime you have something that's like this in the bottom with just an x squared, something like this x squared can go into this first term, and this term. So you would want to rewrite this first. We're going to rewrite f of x as follows. If I could take x squared out of all 3 of those terms up there, what would x to the 5th become?
X to the 3rd.
How about 3x to the 4th over x squared? What would that become?
3x squared.
And then how about 7x to the 3rd over x squared?
7x.
After the rewrite right there, is it a little easier to take your derivative now? Okay, and what would your derivative be after the rewrite?
2x squared minus 6x minus 7.
Okay, so you said 3x squared, is that right?
Yep.
Minus 6x?
Minus 7.
Very good. So something like this, if you see any kind of fraction right here, whatever's in the bottom, you're trying to get it where somehow.
To the top.
Get it to the top if you can. Okay? Guys, example 3, guess what we're still doing?
Using shortcuts to differentiate.
We are still using shortcuts to differentiate. Good job there. Iggy, you are so good at this.
Thanks, man.
I'm gonna sit back and take a break here for a second. Legs about to fall off. You bet you can. Okay, friends, let's talk about these that we're still trying to work on here.
Ours is the assembly after this hour.
Assembly's after third, I think, today, isn't it, guys?
Yeah, it's after third.
Who's working that today? Anybody working that? It's after third hour, isn't it, girls?
Yeah.
I think third hour ends at like 11:10 or something today. All right, let's see what we can get into here. Dive into example 3 here with some more derivatives. All right, I want you guys to talk to me about how to handle this here. I don't like this at all. Okay, I'm gonna call this, first of all, I'm gonna rewrite this as f of x. Okay, help me out, kids. This cube root of x, I could probably call that x to what power? Did I hear somebody say 1/3? Call this 9x to the 1/3 to start. Everybody agree with that?
Yeah.
Okay, how about that 10 over x squared? How can I write that so that x squared's up top?
10x to the negative second.
Say it louder for me.
10x to the negative second.
Okay, good. 10x to the negative 2. Do we all agree with that? Okay, this next one bothers me a little bit. I'm going to put plus 3 over 2. I'm spilling over to the side. You guys don't do that. I don't like that cube root of x in the bottom. First of all, couldn't that cube root of x right here be written like we wrote this cube root of x? And how do we write that cube root of x by the 9?
X to the 1/3.
But since that x to the 1/3 would be in the bottom, we would have to write that, then we moved it to the top as times x to the what, really?
Negative 1/3.
Okay, do you guys all agree how I've rewritten this so we can at least apply a power rule? First question.
So did you just take the x out of the entire fraction, or did you put it, is that x supposed to be in the numerator, x to the
Technically it's up top, but if you move it to the side, the assumption is that it's up top already. Does that make sense?
Yeah.
Here's the deal on that. Ellie, maybe a better way to think about it is this. If I change the sign on the x, no matter where it is, if it was in the bottom to start, if I change the sign to it, the assumption is that it's now on the top. Does that make sense to you?
Yeah.
Okay. Let's differentiate, kids. First part should be pretty easy.
3x.
This becomes f prime of x equals, okay, what's 1/3 of 9 when we pull this out front?
3.
So I can call this 3x to the negative 2/3 power. You okay with that?
Mm-hmm.
Do you understand the negative 2/3, my friends?
Mm-hmm.
Because 1/3 minus 1 would be what?
Negative 2/3.
Negative 2/3, right? Be careful on the next one.
It would be plus 20x.
I plus 20.
Yeah, plus 20. Oh, because the negative times the negative
Yep,
is
so
what?
the negative 2 times the negative 10 makes that a plus 20.
Over x to the 3rd.
Yeah, and I'm just going to go x to the negative 3rd right here to start. We can come back and polish this better. Help me out with this next one. I'm going to be really impressed if you get the proper coefficient. Okay, first of all, what's a negative times a positive going to be?
Negative.
If I took the negative 1 times the 3 up top, that'd be negative 3, right?
Mm-hmm.
If I took the 3 times the 2 on the bottom, wouldn't that be 6?
So you guys 1/2.
Yeah, 3 over 6 will be negative 1/2, so I'm gonna write this as minus 1/2 x to what power?
To the negative 4/3.
Negative 4/3, awesome, you guys. Now again, on a quiz or test, if I said, hey, find me the derivative and you gave that to me, are you gonna get credit on that?
Mm-hmm.
Absolutely. The way they're probably gonna write this, alternatively, they're probably gonna write it as, okay, since this exponent is negative right here, they're probably gonna write this as 3 over,
2.
okay, you want the real way they're gonna write this?
Mm-hmm.
I can write this as x to the 2/3, but they're probably gonna write this as the cube root of x squared. Okay, just stop for a second. If I moved x to the 2/3 to the bottom, do you understand like the 1/3 part is like the index for that? That's probably what they're gonna write right there. Okay, 3 over the cube root of x squared. Okay, how are they gonna write this middle part probably?
20 over x cubed.
20 over x cubed. Oops, that's a 3 right there. This would get moved to the bottom, so you would have minus 1 over 2. They're probably going to call this the what root of x?
Cube root of
Cube root of
x
x
to the 4th.
to the 4th power like that. Okay, so let's back up here. Again, quiz or test wise, right here in this row, Carson's gonna be happy. The thing I'm concerned about is when you're doing problems and checking in the back of the book to see if the answers are correct, what you have and what they have may look very different. But do you understand how I took what you gave right here, using your power rules to get to here? Does everybody understand the cube root of x squared here? How about the cube root of x to the 4th right here? You understand that? Okay. I'm not hearing a lot, so I'm assuming we're good here, all right? Which is scary. All right, let's see how well you do. I'm done talking. You guys help me with this next one. Somebody want to volunteer at this?
Yeah, I can.
I'm listening.
Gonna be, so you're gonna move the 4 out in front, so
Okay.
0.25 times 4 is just 1, so
One.
it'll just be x to the 3rd.
Okay, I agree with the first part.
X to the 3rd, and then plus, so the root 5 is gonna go out in front. So would it be root 5
5 times,
times 7. 7x to the, to the root 4?
well, root 5 minus what?
Minus 1?
That's how you have to write that.
Oh.
Everybody understand the x to the 3rd part there first. 4 times a quarter was what?
1.
1, so it became x cubed. Now root 5 right here moved to the front, that was good. We had 7x, and then root 5 minus 1 up there is my exponent. Oh lordy. We're having fraction form. Guys, we're not very good when we have derivatives to take with the power rule in fraction form. How can I rewrite this bottom here?
X to the 1/2.
So this would become like saying f of x is equal to 7x minus 5 over x to the 1/2. Okay, guys, if I took x to the 1/2 into the 7x, what's x to the 1st over x to the 1/2?
X to the 1/2.
So this would be f of x, I'm going to rewrite, equals 7x to the 1/2. Guys, can this x go into anything here with the minus 5?
No.
So So if I rewrite this part, this has to be minus 5. I can't take anything out to simplify. I just have to move that to the top with the 5.
5x to the negative 1/2.
Very good. All right, my friends, let's roll on derivative.
So it would be f prime of x equals 3.5
Yep.
x to the negative 1/2.
Okay, negative times negative for the next part.
Plus 2.5 x to the negative 3 halves.
Yep. Subtracting 1. Now again, quiz or test, am I okay with that? Absolutely. What are you going to see in the context of your book probably? F prime of x is probably going to be, well kids, they're probably going to move that x to the negative 1/2 where?
To the bottom.
To the bottom where it will become x to the 1/2. But x to the 1/2 is really what root? So this part right here in the front is really 3.5 over what?
Square root of x.
Oh boy, oh boy, oh boy, oh boy. This next one's going to be plus 2.5 up top. Bottom would be,
The square
okay, we move that to the
root
bottom,
of
it's x to the 3/2, so it's really the square root of x to what power?
a third.
So it's really the square root of, oh boy, I screwed that up. Hang on. It's really the square root of x to the third is what you'll see. What do you guys think so far?
Solid.
I feel like your brain's a little fried right now. I've done a good job frying brains today. First hour I had fundamental theorem of algebra. You guys are getting all these derivatives. Let's do example 4 and call it a day. How's that sound? We'll finish the rest tomorrow. Fair deal? Example 4 says a derivative application right here. It says find the intervals where f prime of x is greater than what?
1.
1 if f of x is what function?
X cubed minus 4x squared minus 7x plus 8.
So guys, we need to figure out where the derivative is greater than what value?
1.
1. Well guys, do we even know what the derivative is yet for this?
No. But we can find it.
We can find it. So let's start with f prime of x. What would f prime of x be in this problem, kids?
3x minus 8x. Oh wait, 3x squared minus 8x minus 7.
Okay, so we have f prime of x, right? And we want f prime of x to be greater than what value? 1. Okay. And probably, this should probably say greater than or equal to, kids. So put an equal sign underneath that. All right, here's the situation. What we're really asked to solve right here, kids, is this. We're really asked to solve 3x squared minus 8x minus 7 greater than or equal to 1. Okay? Guys, I work really well when there's a value over here of 0. Okay? Because when we get things equal to 0, we can start trying to factor some things. So let's try this. Gosh, did I screw this one up? Probably, but oh well. Let's subtract 1 from both sides, okay? So we are in a situation where this says 3x squared minus 8x. Oh boy, what would that be, guys? Minus 8?
Yeah.
Is greater than or equal to what?
0.
0. Okay.
guys, here's what I would really like to do. I'd really like to know where this function is equal to 0. Okay? So, here's what we do. I'm going to try and factor this as much as I can. This is a quadratic, isn't it, kids? For my quadratic, do you guys agree that I can factor this into 3x and 1x right here to make the 3x squared up front? Agreed there?
Wait, what?
3x times the x would make the 3x squared right here when I factor this, right?
Yeah.
Okay, help me out, kids. We need to think of some numbers that multiply to -8 that we can try and guess and check to get this middle term of -8. So give me some numbers that maybe multiply to -8. Is it okay if I try -4 and 2? Might have to guess and check. I'm going to try -4 over here. Okay, and I'm going to try plus. No, that's not going to work. Son of a gun. Let's see, -2 plus 4. Gosh, is this thing gonna factor, guys?
It's unfactorable.
Can I try something real quickly?
Go for it.
I think he's thinking.
It's like the,
It's loaded.
yeah, like the loading.
Son of a biscuit. I wonder if I wrote that down wrong.
Oh no.
Somebody jump into, now let me jump into decimals real quickly. Somebody tell me what this function setting is. I'll bet I typed it in wrong in our notes. Okay, somebody read that function to me. X to the what there?
The one that we want factored.
I want f of x. No, not the
Okay.
factored one. I want the original function that we
X
start with.
X cubed.
X to the third?
Yeah.
Is that the derivative that you're giving me?
No.
Or the original function?
This is f of x.
Okay. So x to the third, you said?
Yeah. Minus 4x to the second. Minus 7x. Plus 11.
Dang it, I screwed this up, didn't I? God dang it. Oh, that was supposed to be plus 9. Need 2, 1, 5, would have been 10. show you what we're gonna do, all right? Since I can't factor this, take this part out, all right? Okay, if we can't factor, make a note down here, if we can't factor this, because it's gonna be possible at times. And 4 and 2, 8 and 1 would also work, right, but that's not gonna help me. What times to negative 24 and adds to negative 8? Nothing, right? Okay, no problem. Here's what I'm gonna tell you to do. Get in decimals. Okay, and we're gonna type in our derivative of 3x to the second minus 8x minus 8, and we really want this to be greater than what value here, kids?
Minus 8 or minus 7? Wait, oh, just kidding,
Well,
just kidding.
yep, we're gonna do the minus 8, and I'm gonna keep it relative to 0, because if I keep everything relative to 0, okay, that allows us just to look at the x-intercepts on the x-axis and see that very clearly, okay? And we're gonna want to know where that's greater than or equal to what here, kids? 0, okay? So go back to decimals. I'm gonna leave that original function up there even. I'm gonna get really sassy about this now. Oh, I'm fired up. Okay, what was the derivative again that we're dealing with?
3x squared. Minus 8x. Minus 8. Greater than or equal to 0.
Okay, and we had said, what was the original problem? Was it plus 11 up there?
Yeah.
I'm gonna put the original in. Okay, I'm gonna take this function out right here, all right? Oops, come on, go away. There we go. Okay, the question becomes, where is your derivative greater than or equal to, what do we have it set up compared to?
0.
0 right now, right? But that would be the same as this mess, greater than or equal to what?
1.
1. Okay, so what we do here, guys, is this. We come into decimals and we say, well, this is my derivative function right here. And I have zeros at that value and at this value, right? Where's a function greater than 0 at? Well, you tell me that would be, or the derivative is greater than 0 everywhere above the x-axis, right? So wouldn't that be for x values left of negative 0.775
Yeah.
and right of what?
3.442.
Okay. I'm gonna go back in here. Can you remember those values? Negative 0.775 and 3.442?
I got the 3.442.
So this would be for x values less than the negative point, what was it, 775, kids?
Yeah.
And x greater than or to the right of, what was it, 3.442?
Yeah.
Okay, what this is telling you guys is this. And we're gonna stop after this one today. If I go back into decimals and go back to my original function, oops. Tell me what those x values were again. X was equal to negative 0.775.
Yeah.
And what was the other one? 3.442.
Is this?
Okay, well, let me just show you what this is telling you, guys. It's telling you everything left of this line right here, everything left of this line right here, left of the green line, every slope here left of the green line is more than what?
1.
Steeper than 1, okay? Everything to the right of this blue line, slope would be steeper than what? 1, right? Okay, so everything over here on this graph, even if I zoom down a little bit, that does not work. If I zoom down a little bit on this, everything to the right of that purple line is going to be slope greater than what? And everything left of the green line is going to be slope greater than what? 1, okay? That's a good place to stop. I'm sorry that didn't factor. It was supposed to factor nicely. I'll find one that does, okay? But if it doesn't factor nicely, where can we go? Uh-huh. All right, very cool. You guys enjoy your day, all right? Hey, Tuesday for corrections, all right?
Why don't you work up to it, Dan?
Is where you just throw it on the spotters, and you do it.
No, you
Yeah, I like to put a nice tape to the bar. I wanted to do fail. I'm dead. And
Dan would do that too.
I saw that before. I actually wanted to try it once.
Get a couple extra reps.
Yeah, Jordan will be kicking. They win you
Unless you want to try it.
Bro, we can stop.
I'm never gonna stop.
Yeah, but I
Just had a
I was probably like elementary.
Yeah, obviously you guys like that.
No, I know, but
Shit, I'm sweating.
I saw someone drop 500 pounds of chest press.
Hey, you want to do the suicide rep? You guys do it.
That's where I'm headed.
That is how it rolls. You can't imagine dropping something like that. 500 pounds of weight. You bring like ribs.
When we're noise,
I've dropped 220 to have a ladder today. Didn't even get it.
drop 225.
Because it was like 250 like my own racket, my wrist cramped, and like my wrist cramped the top of the thing, so like a white belt.
Oh my god.
Yeah.
You don't always ever go to the gym by yourself.
I go with my dad.
But then,
Mine's big and strong, don't lie.
yeah, he's not very big, he's just tall.
He's 230.
Yeah.
Reminder that when the bell rings, you'll be going the third hour. Report to third hour. Also, if you have study hall, third and fourth hour today, you're going to be reporting to the odd for third and fourth hour study halls today.
You're not cool. Don't do it.
I gotta check my fantasy football soon.
We're just exercising.
Yeah, like the eye roll on that one.
What?
The eye roll.
Yeah. We were just bumping.
Oh, hey, you guys have a good day.
We were down there.
I doubt we will at all then, because Doran can't either.
Yeah. I thought it was like, we're practicing during third hour.
Oh, okay.
90% sure. Yeah, like, I'll be practicing.
Low.
Serving the meal.
There you go.
Rep the LA.
It's kind of funny. It's really Rubbing my time zones.
Yeah, that's all we're doing. So there's no assignment. We're not gonna finish today.
What's for lunch?
I don't even know what the date is. November 11th. Mini corn dogs. Oh, Ellie, but it's so funny to see you here. Dude, you wanna know something? Last night, me, Ellie, Charlie, and Aubrey, we all showed up at the church because we thought we had youth meeting last night. There was no youth meeting. Me, Ellie, and Charlie were all rolling around in wheelchairs. Yeah, we were riding in the hallways. Is your hand? How's your hand? She like got good. She got like stuck in the wheel. She was like going like that. I was like,
Okay, guys, help me with attendance. Ellie's here.
In study hall today or gym?
How about Cody? Anybody seen Cody today?
the
Is
hallways.
Asia here today?
She is here. She's like helping with something.
No, I did not tell you.
Apparently we're having a meeting now, so I have to go.
Did you see Joe's story? Or read Joe's TikTok? That doesn't make her good. No. This? She got like 8 toys and like 5 toys. They already chew that. Well, no, we get indestructible toys and they get destructible. Grabbed them. It's so weird. Look, ready? No. They were like,
Alright,
they get her, like, so inspired. I'm going to do something. I did not go with it. We can't leave toys in a key like when we leave for the day because it just destroys it.
Oh, I think nope, I got that right.
I know. Carson,
Yeah.
would you be willing to be in one of my TikToks?
What?
Would you be willing to be in one of my TikToks?
What do I have to do?
Hang on, let me find a version of it. And I'll show you. Like close, and you can hear it like all right here.
Talking about the fundamental theorem of algebra.
He does that to tennis balls too.
He's in Taylor. There you are. I almost forgot your name there for a second, little Tay. All right, my friends, quick question. Does anybody have 3.5 that they want to turn in? I think we said some of you turned it in yesterday and got done. I'm pretty sure I said do Thursday or Friday, right?
Yeah.
Okay, so I'm questioning, I can tell you whose I have already. Do I need to remind you whom I have already?
Yes.
Okay, so Dina, I have yours right now, and I think Ellie, I have yours, and looks like. How about either 3.5 to turn in, or any questions on 3.5 before we move on today? Anybody have anything there? You guys know we crossed quite a few of those off yesterday, right?
Right. 2, 4, 6, 8.
2, 4, 6, 8, 10 are gone, 14, 15 gone, anything you said on 16, you should only worry about one of them, right? Anybody have questions, or anybody have one to turn in for me?
I don't.
Okay, if not, I'm gonna get you the new notes. There's no new assignments, so if you've still got 3.5 that you're working on, get that stuff to me tomorrow if you can. Oh lordy. Guys, I'm having quite the day today.
I wish it was Friday.
I do too. It's only Thursday. Well, I think we know why our week is going remote control and my coffee, and I went and laid down, started watching.
What?
I have a business
It's not.
Hey, did you guys get a group chat started last night? Did you get an order in?
That's cheap, okay.
I need someone to
It's
give me
like
that list.
$9 for a
I need someone to
burrito.
give me that list.
$14 for the burrito. Yeah. Like,
You would get a chance at the end of the hour right
okay,
now.
so.
Or I guess I could do it first thing tomorrow morning too, but I'd like to put the email in today because they're really good to me. When I tell them I have a team that I'm getting it for, they give that stuff to me really cheap.
Yeah,
So.
I'll try and get it.
Did I give you one already, Cody?
I wish I got one.
You're fine.
Good job.
Should've said no, so I guess, well, not that you were here, but just helping with something. So we didn't count the absent or tardy.
Oh, I see what it says out.
She hasn't even talked. I mean,
work to shit for hiding. Yeah, I think
That's me. And this is you.
I have to do this.
Yes.
I can't do that.
No, I believe in you.
Wait, show me. It'll look bad.
But nothing told me.
Have to go.
You gotta, here, actually, let me show you a better one.
Oh my gosh, Jason, are you making me do it?
Yes, I'm making you do it.
Oh my gosh.
Because I believe in
You
him.
guys can throw some.
Is it the teacher one?
Yes.
Yeah.
That went on the
Fix them
board.
already.
Ew.
No, I was
Set 'em up
wondering.
there.
Yeah, I just checked off.
Yeah, I did.
Okay.
I need to work with him.
Did you get notes here?
Yeah, I got those.
I hope so.
Okay.
Wait, who?
There's an extra one.
You guys brought it up?
Why not?
Okay.
You were like, oh, is this the teacher one? I was like, yeah.
All right, Hayden is gone.
That's for you. I really told you.
Who else are we missing? Daisy?
yeah, Daisy's gone.
Daisy.
What does that mean, Queen?
Girl, you can let me slap her back.
What? You're crazy.
I have one more then. I was being nice. I'm gonna steal you today.
She's always at work.
I'm such a crackhead.
Okay, my friends, today is gonna get, oh boy. You guys ever had conversations with people, you were talking to them, but you weren't really listening to them, and then you know if they were telling you something important, you're like, wait, I'm sorry, they need to tell me that again.
Yeah.
You ever said that before, or done that before?
What?
I do that to my wife all the time. My wife will just be yapping, and I'll be like,
Let's get
watching sports or something. Like when I'm watching sports and my wife starts talking to me sometimes, and she's like, Justin, I'm like, what? And she's like, did you hear any of that? I said, no, I'm sorry. The race is on, or something like that. You guys ever done that before?
Yeah.
Okay. Today is one of those things today like this, where the notes are going to speak to you today. The notes are going to speak to you today. All right? And this is going to be one of those deals where if you don't listen to what the notes are speaking to you today, I don't know if you'll figure it out. So you want to make sure you pay really good attention today, because I'm going to go on offensive today, and I'm going to say this might be the hardest lesson we have all year. Oh, you should say no. You should say, bring it on, Parson. That's what you should say. Bring it on. I'm ready. Yeah. Bring it on.
It's imaginary.
It's going to involve imaginary numbers, but it's going to involve a lot more than just imaginary numbers. Now, I need to get the right notes loaded up here. We will not come close to finishing today, okay? So therefore, no more assignment. Just finish 3.5 stuff, okay? We'll get the vocabulary done easily. The vocabulary, you actually know pretty much most of it anyway. Okay, here, nope, that's calculus. You guys don't. Look at what calc is doing. How would you like to do that? All right. Yeah, you don't want this, folks. Trust me, you don't want this at all. Kids, I'm still recording.